Okay, so we are live.
Hi.
We are going to look at some more trig graphs in a little bit more detail today. So let's see, I'll just make one up. So I'm going to draw a graph. Okay, we're going to scale it like that on the x-axis, the y-axis. Let's go by tens. So go by tens on the y-axis. The x-axis is going by those course 2's, right? And I think I'm going to draw a wave function. Notice, am I making this problem up? Aren't I making it up the same way that you graph these? Okay, that's pretty good enough. We want to figure out what is that function.
F of x equals.
Once you're good at this, you're going to be able to do it pretty quick.
Well, it is a cosine function.
Negative 20.
It is a cosine function. It's negative cosine function.
Is it only a cosine function? I like you guys. You guys are thinking right. Good. Good stuff.
It could be secant.
It could be sine or cosine always. I only want one of yours, but every single one at the top of that worksheet, they can all be expressed as sine or cosine if you phase shift them. So let's write it down both ways for this one, and then it's all your choice on the worksheet. I just want one, okay? So there's usually an easier way and a harder way. You guys are saying the easier way is to use?
Cosine.
Cosine, I agree, and not a positive cosine, but a negative cosine, because it's kind of starting down. Very good, you guys are on the road. Now, I need to think, let's write some details down, just like we would if we were trying to graph it. What's the amplitude of this thing? Be very careful.
Amplitude is 15.
Don't like this marker anymore. So close. What is the amplitude? Do you guys hear Nick?
15.
He's got it. Do you see the 15?
No. Because it goes from negative to
How wide is it oscillating? The width of the corridor of oscillation is how much?
30.
20 plus 10, that's 30. That doesn't mean the amplitude's 30, because it's not going up and down 30, is it? It's going up and down 15. So shouldn't we probably put like where the middle of this guy's at?
It's
Where's
at
the
negative
middle
5.
of it at?
Negative 5.
It's at negative 5. That's kind of sneaky, right? I tried to make a harder one than yours. You guys agree that it's negative 5, so that it goes up 15 to 10 and down 15 to negative 20. Is that right? So I think we're right. So that we've got to shift down 5, right? So we're going to have to put that in our equation. Okay. I think the part you really need to focus on until you develop some intuition. You'll get some intuition after you do some of these, but at the beginning you're going to have to be real careful. The period is going to be the thing that's the toughest. How often does this thing repeat? Look for one cycle. You can start here, or you can start it down here. It's up to you.
4, yeah.
Looks like I did 4, yeah? From 0 to 4. And then this one looks like it's 2 to 6, so we're thinking 4 for the period. All right, let's write that down.
The amplitude will be negative because it's starting at the...
And you guys said there's like a negative reflect over the
y-axis. No,
x-axis.
Yeah.
So, and then you guys said let's do a negative cosine. I like that. That's all good information. So now let's put it all together.
F of x equals negative 15.
Good. Good, Nick. So f of x equals,
Negative 15.
we said it's a negative cosine, but the amplitude is 15.
Cosine.
I don't think we've figured out what to put in that box for the period. Should I, since we said the period is 4, should I just go 4x now?
No.
That's not the way that works, is it?
The period would be
It's like 2 pi and stuff. You can do this intuitively. Maybe it's 8. I don't know. You can guess it. Once you've done a few, you'll be good at guessing it. But right now, let me show you the way to do it if you're having trouble. Okay.
1 pi over
What goes in here?
pi over 2.
The period we said equals how much?
2 pi.
2 pi.
4.
Or no, we said it was equal to.
4.
Fooling me there.
I was like, you have to divide.
But did I put it over there? I'm going to write it like this because when we do the period, it's usually, what do we start with for cosine?
2 pi.
Everything except tangent to cotangent, you start with 2 pi and you divide by
4, so it'd be
the
pi over
thing,
2.
right? You divide by, let me put it in a different color. You divide by the thing, b, I don't know if that's going to show up in my video. So you say the period is 2 pi divided by that b, but we said the period was equal to what on this graph?
4.
So we can put a 4 right there and solve for b. Does that make sense? And then you'll know what to put in that spot. So you go up, divide. So b is what?
2 pi over 2.
So that's what we need to fill in this blank with. Is pi divided by 2. Did we cover everything?
Couldn't you have put in, for Mr. B, for B, couldn't you have put in 4 and it would have still given you the same answer without?
Did I put in 4?
If you put 4 on the in for B, like without having the equation or anything, just say 2 pi over 4, it would still be pi over 2.
Then the period, then this would say pi over 2.
Okay.
So no. A clue is if your axis doesn't have pi in it, what should be in here? Pi, because they like cancel. If your axis has pi in it, should you have a pi in there? No, but you're going to develop that intuition after a few examples, okay? I'm going to just check these off. Do we have this?
Yes.
This?
Yeah.
Oh. Where do I do that?
Outside, minus 5.
Okay, check. We did that a lot, check. We put the minus in and we did this thing. I think we're good. So there's one. Can you do this with a sine curve?
Yeah.
Yes, sir. That's just going to be harder on this one. I'm not saying you have to do both on your worksheet, but let's just do it just in case. I think most of that stuff's going to stay the same for the sine curve. There's only one change.
Phase shift right.
We've got to phase shift this thing somewhere. Let me get a red marker. I want red. Okay, can you guys see where the sine curve would start? Look around here.
Yeah.
If it's the sine curve, doesn't it start right there and go like this? And that's like the first period of the sine right here.
Yes.
So we really are looking at this spot specifically, are we not? And we want to shift it right or left? Right. By how much is that? 1. So this one was pretty easy to see, yeah? So if we want it to be a sine curve, it's going to be right 1. And the sine curve, we'll call that g of x. It's really equal to this, though. It's the same thing. So maybe I shouldn't call it g of x. Let's just put it equal. It's the same function. It's still going to have the same amplitude and shift, isn't it?
Yeah.
So I think it's still going to be 15, but this time we're going to put sine. Still going to be down 5, except we said it's going to go right by
It's gonna be negative.
1, so minus 1. We've got like an x minus 1. We're going to have the same period on it. I don't think we need a negative sign, do we? So is that right? If you were unsure, you should do what with it? Calculator. Yeah. It's not right. It's not going to be right. If you see it in your calculator, these are going to be like shifted the wrong amount. If you look at it carefully. What's up?
Wouldn't the origin be at 1 negative 5?
Where at?
1 negative 5.
Yeah.
Oh, yeah. Good point. Thank you, very good. I think it's still going to probably be a shift of 1. Though. Maybe we're a little bit off. Let's just say 1 though. We're pretty close. Good enough for our purposes. Good question. Good. Okay. So something's wrong here though. I need that. If you look at the form, if you don't have that extra set of parentheses, this pi over 2 is affecting the 1 and making it something else. If you, whether you see it or not, it's changing the 1. So the way to think about that is we need to fill in this blank, okay? So we're going to put in those extra parentheses like we want them. We know we want this to end up being 1, right? But that pi over 2 is being distributed to it. So you can guess, because sometimes it's hard to factor, yeah? This is like factoring. So let's guess, what should that be if we want to get a 1? Well, the thing is, I'm thinking backwards. Sorry. Once I put that in, now I'm good. If you put those, don't have those parentheses there, think about when you distribute this. What would it be? It'd be inside, you'd have pi over 2x, and you distribute that, and you'd get
Minus pi over 2.
minus pi over 2. Do we want it to go right to pi over 2?
No.
No. See, that's the thing. If you didn't put those parentheses there, it wouldn't safeguard that. So you've got to put an extra set of parentheses here so that it actually shifts over 1, or it's not doing what you expect it to. Let's see another example so we can kind of look at that again. So I kind of mixed some words there. So we'll look at another example as well. My point is double parentheses. If you have a phase shift, you better make sure you have two parentheses here, so that you can actually make sure it's actually shifting the amount that you want. For example, let's do one of those ones at the bottom, shall we? You guys can pick. Which one should I do?
21.
Some kind of cotangent or tangent, something else?
25.
Maybe 24. 24 is tangent. I think I should do a tangent one. Maybe not.
I think 21.
Yeah, 24 then.
Or 26.
Okay, 24. We'll do 24.
Is this one divided by?
It's done. I don't know why 20 is bigger.
Okay, that's a good one.
No, because the 7 times 3.
So I want to graph this. They say to use at least 2 periods, lots of detail, blah, blah, blah. Okay, somebody tell me, what am I going to have to do to it?
Shift it left pi over 2 units, right?
Nope. I bet a lot of you guys are like, what? I think Nick's right. Does it have double parentheses?
No.
It's not actually going left by pi over 2. This 3 is affecting that number. So you've got to say factor inside here. So I'm going to use a couple pairs of parentheses. I'll use some brackets to clarify. And I'm going to factor that 3 outside to see how much it's really being shifted left. So how much is it really being shifted left? If I put...
It's 3 pi over 2. Because
Is it?
3 times pi over 2.
Some of you guys I know are going to have trouble filling in this blank. So the best way to do it is to guess and check. So you're saying 3 pi over 2? Let's see if he's right. So he's guessing this.
Well, that would be the answer if you factor it. What I was saying is 3 times pi over 2. I'm not saying that would be the...
Well, let's just guess. That's a guess, yeah? It's a legit guess. So now distribute this back through and see what you get. What do you get when you distribute?
That's it.
9 pi over 2. Is that equal to this?
No.
So that's not it. Another guess.
I'll tell you once.
If it's just 2 pi, that's going to be 6 pi. How about 2 pi over 3? That's probably a good looking guess. So you get 6 pi over 3, which is
1.5 pi.
2 pi. We want a half pi though.
How about pi over 2 divided by 3? Well, okay.
What is pi over 2 divided by 3? I think that's exactly what you're supposed to do.
Pi over 6?
Pi over 2 divided by 3 is,
Is it pi over 6?
yes, a half divided by that. If you're unsure, you should be writing it out. You guys should all have this skill of being able to write this out. If you have a half divided by 3, then write it out like this if you're unsure. Flip it,
2 over.
and you get pi over 6. Right here, this kind of computation is invaluable. If you can't do this, your math career is over in about a year. So, be clear. So that's the guess. Are we sure it's going to work? Distribute. You get 3 pi over 6. Is that a half?
Yes.
Yes. Very nice. Took us a few guesses, so sometimes you have to guess on that, right?
That's not what you do every time. Just do 5/2 divided by 3, or
That is what you do every time.
Okay.
I just think that's a rule that people get confused, so it's not like the guessing, but yes, use that rule. And then I make sure do a quick mental distribute to check. Good. Okay, so now we're good. We finally can see what's happening. We've got a reflection, right? So we're going to flip it over this way. The period is
Well,
starts out as pi for tangent, and you divide by that thing, so 3. And we've got a phase shift of left pi/6. Now we can see it. Okay. So I think this is one of those ones where we should probably do some scratch work. Maybe it'll work out. But this, the width of the asymptotes, so we're going to be straddling or not, you guys?
we will.
Since it's tangent, yes. If it was cotangent, no. This width is pi/3 for a period, yeah? So since it's straddling, we're going to start out at, this is just like that one I had earlier, darn it. So we've got a 1/6 both ways, and we're going to take this asymptote and shift it how much?
Left. Pi.
Left, so instead of just negative pi/6, it's going to be
Negative pi.
negative 2 pi/6, right? Which you can simplify to a -1/3, but I'm just going to leave it like that. So instead of negative pi/6, I'm going to go negative 2 pi/6, or 1/3, negative 1/3. And then we said the width of this is supposed to be 1/3, so we're going to count by 2/6. This is 2/6. Yeah? So I'm going to count 1/6, 2/6. Looks like one of the asymptotes turned out to be right there. Then I'm going to count 2 more 6 for the next asymptote. I should really be writing these as x equals, right? Count 2 more 6 for the next asymptote. That's probably plenty. And now I'm going to graph it. So we took care of that. We took care of that. We only need to worry about the flip. So tangent usually goes like this, right? But if you reflect it and flip it over, what's it going to look like? It's not going to look like tangent anymore. Now it's going to look like cotangent. Now it's going to look like cotangent, and it's going to go like this, right through the middle. Down like that. Down like that. And see, we already counted these out, so we know where these are. If that's 2/6, then this is 1/6. 2/6, this must be 3/6 or a half. This must be negative 1/6. So we've got all the intercepts and all that stuff too for ourselves. So it's all about that counting. Got to count like that. And what's craziest about the final result? We started with like a tangent curve, right? I thought tangent was supposed to straddle the origin on both sides and look like this.
And it ended up looking like a cotangent function.
It ends up looking exactly like a cotangent function, doesn't it? Because it's not straddling, it's shifted over this way. And since we reflected it, it flipped it over, and it looks exactly like a cotangent function now. So can that happen on some of yours?
Yes.
Yeah, but that's the same thing as the last one. Can a sine be a cosine? Yeah, if you shift it and do the right stuff to it. Can a tangent be a cotangent or vice versa? Yeah, if you shift it and do the right transformations, it can. Okay. All right, I'm going to let you guys go with that, I think. We'll leave it there for now. So make sure you spend some time, pay attention to the details. It's going to take some time.